Hey everyone, welcome back to our channel. Today we are diving into the world of Go and we'll be exploring how the Go compilation process works. Whether you're new to Go or just curious about how it all fits together, this video is for you. So let's get started. And we know that Go is statically typed language, a compiled language which is designed at Google. Okay, so it's known for its simplicity, efficiency, and excellent support for concurrency. But how does a Go program go from a written code to executable binary? Let's break it down. Okay, so let's understand step by step. First, what do you mean by compilation? Okay, so compilation in Golang is the process of translating Go source code into an executable binary. As we have discussed, we'll be writing in English words, right? So whatever the code which we are writing will not be understandable by the machine. So it has to be converted into zeros and ones. That is the binary code. And this process can be done a special program called as compiler. And that process is called as compilation. Okay. And this process is handled by the Go compiler, which checks the code for errors, optimizes it, and generating a platform specific executable file. Okay, so what we can say is we told that it will convert your source code, that means the code which you are writing, into the machine code, that is zeros and ones. Not only that, Go compiler is even capable of finding the errors and optimizing your code as well, and still it does many other actions as well. Okay, so what does the Go compiler do? Let's break down it. So the very first thing is the main functions of compiler is it will perform lexical analysis. That means the compiler will read your Go code and it will break down it into tokens. Okay, so tokens are nothing but smallest units like meanings like keywords. As we have discussed in the first Go program, we wrote some code, right? And in that we have some keywords which are reserved words by Go language itself. Like we have func, we have package, we have import, and even we have identifiers which are the names given by us for the variables and functions. And we have operators, and still we have other symbols, right? So what it does is it breaks down the entire code into tokens which are the smallest units. Okay, so it performs lexical analysis. It will read your code and will break down into smallest tokens. So that's the very first thing what our Go compiler does. And next, it passes the tokens are then organized into a syntax tree that represents the grammatical structure of the code. So this will help the compiler understand the logical flow of the program. Okay, and not only this, it will check your syntax. It performs syntax analysis. So the compiler checks if the tokens form a valid program or not, and whether they are according to the rules of Go or not, whether they are aligning with the rules of Go or not. Okay, so if there are any syntax errors, suppose if you forgot to add a curly brace at the end, or if you have a typo, so these kind of syntax errors will be detected by the compiler in the early stage itself. Okay, so the compiler will immediately throw an error and it will stop the compilation process. Okay, so the compiler will check your tokens whether that forms a valid program or not, and whether they are aligning with the rules of Go or not. So the second function of compiler is it performs syntax analysis. And next, it also does something called a semantic analysis. Okay, so the compiler checks if your code makes sense or not. For example, it verifies that you are not trying to use variables that are not declared, or you are not calling functions with the wrong number of arguments. It will check each and everything. So it will check each and every semantic, and it will halt the compilation process if anything is missing. Suppose you haven't declared a variable but still you are trying to use it, so that's not a good idea, right? So it will perform semantic analysis and it will be able to tell a clear reason why the compilation got halted. Okay, it will give you a clear reason that you are trying to access an undefined variable in this kind of a meaningful message. Okay, and then type checking. So the compiler verifies that all the expressions in the code adhere to Go's type system or not. So it checks for type correctness and ensures that there are no mismatched types or invalid operations. Okay. And the third function of compiler is semantic analysis and optimization. So the compiler even tries to improve your code, making it run faster, or it will make it to use less memory as well. Okay, and not only this, even code generation as well. The compiler translates the syntax tree into intermediate representation. Okay, so which is then converted into machine code, that is zeros and ones, specific to the target architecture. Okay, it will even does the code generation as well, and even it performs optimizations, like it improves your code, it will make it to run faster, and it will make it to use less memory as well. So this is the most important function of the compiler. And we have discussed about this code generation, right? So the compiler will translate your optimized code into machine code, okay, creating an executable file which is 0 and 1. So what we can say is, and even one more thing, we have something called as linking as well. Even that is performed by compiler. So finally, what after all these steps, after all this analysis, finally the compiler links together all the pieces of machine code along with necessary libraries and the dependencies which you have used while writing the code, and it will produce the final executable file. Okay, so after successful compilation, it will produce an executable file. So if you are using Windows, the executable file will have an extension of .exe, whereas if you are using some kind of Unix based systems like Linux or Mac OS, it might be just the name of the file itself, like main. Okay, no extension. So you can run this executable file to see your program in action. Like you can run anywhere. So you don't want to have the source code again. You just need to have this machine code and you'll be able to run your program. Okay, so these are the main functions of compiler. So not only converting from source code into zeros and ones, other than that, apart from that, it even does many things. It even does many functions which are very required for a computer or for a program to run efficiently. Okay, so these are the main functions of compiler, and you can ask like, see, why is it important? Like why compilation is important? Very simple. See, performance. So compiled programs generally run faster because they are translated directly into machine code, right? So the computer will be able to easily understand it. Like it will be able to easily execute it. And even it does error checking. So it will help catch errors before even you run your program. So making debugging easier as well. Okay. And portability. See, once compiled, the executable can be run on any computer with the same operating system and architecture without the need of original source code. Okay, so these are some of the reasons why compilation is very much important. Okay, and now let us see in action. This is the code which we wrote in the previous session. Like this is a very first Go program which we wrote. Okay, so this is the source code with the extension .go, and this is readable by humans. We are able to write this, that means it is understandable, and we can say that it is in high level language. Now we want to convert this into zeros and ones, and we told that compiler will be able to do it. And how to do it? Very simple. We should give a command in Go. We are telling that go build and the file name main.go. Okay, so if you give this command, immediately an executable file will be created. Please focus here in the folder section. You can see a new file getting created with .exe extension. So now we'll enter this command, and immediately you can see that we got something called as main.exe. So that is the executable file. So which will be in zeros and ones, or you can consider it as gibberish as well. If I open with VS Code, okay, if I click on open anyway, you can see that it looks like gibberish. Okay, but end of the day it is zeros and ones, and our computers will be able to understand that particular zeros and ones. Okay, so that is how we can create executable files in Go using the command go build main.go. Okay, so and that's the compilation process in Go, from source code to executable. So Go's compiler takes care of everything, ensuring our programs are efficient and reliable. So that's about this session. If you found this video helpful, don't forget to give it a thumbs up, and do subscribe to our channel for more programming tutorials, and hit the bell icon to get notified whenever we post a new content. And thanks for watching, and happy coding.